NASA's most advanced telescopes suddenly go into emergency override. Alarms trigger, schedules are wiped, and astronomers around the globe scramble to capture a new object hurtling toward our solar system. The intruder has a name, 3I/Atlas, an interstellar comet arriving from another star system at an unimaginable 150,000 miles per hour. But what the telescopes revealed within minutes shattered everything scientists thought they knew about comets. Instead of the familiar fuzzy ball of ice and dust, 3I/Atlas was breaking apart into sharp, metallic-looking fragments, glowing like shattered glass drifting through space. No dust tail. No icy coma. Just angular debris flashing unnaturally bright against the blackness. And that's when scientists realized something was very, very wrong. The first alert came from Rio Hurtado Observatory in Chile. At 5:08 UTC, their telescope uploaded fresh images into NASA's Center for Near-Earth Object Studies server. Within seconds, her notes spread across time zones. Astronomers were jolted awake in the middle of the night, staring at glowing monitors, data streaming in real time. Normally, such alerts would go through long debates, confirmations, and committee reviews. But not this time. Significant outgassing, possible fragmentation. Request JWST urgency. Within minutes, the observation schedules of the world's greatest telescopes, Hubble and the James Webb Space Telescope, were thrown into chaos. Dozens of carefully planned targets, from distant galaxies to exoplanets, were abruptly cancelled. Every lens in the sky was turned toward one thing, 3I/Atlas. Inside the control rooms, the atmosphere was electric. Headsets crackled with rapid-fire updates. Analysts stared at frame after frame, sharp, bright fragments scattering outward with no dust, no familiar chemistry. Someone compared it to glass shards thrown across black velvet. No one had an explanation. But one thing was clear, this was not playing by the rules of nature. By standard protocol, such a request required a full committee review. Half an hour of deliberation. Tonight, there was no time. Dr. Atwood made the call. She keyed in the emergency override, personally authorizing a maneuver that risked Webb's delicate instruments and weeks of planned science. Fluido coordinates. All instruments standby, her voice cut through the mission loop. On the monitors, Webb's primary mirror began to move. Gyroscopes spun, reaction wheels shifted. The telescope realigned from a deep field target to a blank patch of sky, except for one flickering anomaly. By 5:31 UTC, JWST locked onto 3I/Atlas. The clock was merciless. They had only minutes before the fragments moved out of view. For the flight team, there would be no second chance. But where did 3I/Atlas come from? To answer that, we rewind 1 month earlier. July 1, 2025. Inside the Atlas control room in Hawaii, it was just another quiet night. At 3:14 UTC, operations lead Dr. Evelyn Cagevani noticed a strange point of light streaking across the Rio Hurtado feed. At first, she thought it was a glitch. But the track was clean. No satellite. No asteroid. No database match. Minutes later, a junior analyst, Mark Liu, pulled 10 days of sky survey data and ran the numbers. His results stunned the team. The object wasn't bound to the solar system at all. Its path was hyperbolic, an escape trajectory. Too fast to ever return. Object inbound. Orbit unbound. Traces to Sagittarius. Recommend global follow-up. It was official. Humanity had just discovered its third interstellar visitor. Within hours, observatories worldwide were alerted. Pre-discovery checks began. Teams dug through old frames and found faint traces of 3I/Atlas dating back to mid-June. It had been out there the whole time, but its incredible speed let it slip through unnoticed. Back at NASA's command centers, images streamed in, 3I/Atlas breaking apart violently. But this wasn't the dusty disintegration of an icy body. Instead, shards reflected sunlight in jagged flashes. No carbon signatures. No water ice. The chemistry was wrong. The fragments didn't look natural. They looked metallic, like pieces of glass or polished alloy. Astronomers whispered the unthinkable. What if this wasn't a comet at all? The implications were terrifying. If these fragments were truly alien in origin, what did that mean for Earth? Could they be ancient debris from another civilization? Or something far more dangerous drifting between stars? Every telescope on Earth was now locked in. Every signal, every flash was analyzed. The hunt wasn't just for scientific curiosity anymore, it was for answers that could change humanity's place in the universe. As one astronomer later said, when the shards appeared on screen, we all knew this wasn't just another rock. Something about it felt deliberate. And so, in less than 24 hours, the arrival of 3I/Atlas had rewritten the textbooks. A comet that wasn't really a comet. Fragments that looked metallic. A mystery racing through our solar system on a one-way journey back into the dark. The world's most powerful telescopes had caught it just in time. But the question remains, what exactly did we witness? Because if 3I/Atlas is not a natural object, then what else could be racing toward us from the stars? Please like, share and subscribe. Thank you for watching my channel.